Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine the final value in compound interest. And one of the common formulas that we have for compound interest is final value, which is FV, is equal to the present value, PV, times 1 plus R divided by N raised to the N times T. And I wrote up what everything represents. FV represents future value, which is your final amount, which we're going to find, we're determining in this video. PV represents your present value, which is like your initial amount. R represents your interest rate, but make sure that it's in decimal form. T represents the time, how long you're going to invest. And N represents the number of times you're going to compound per year. Now, I wrote FV and PV because present value, future value, that kind of makes sense. But a lot of times we'll also just shorten it to F equals P times 1 plus R over N raised to the N times T. And the reason why it's probably usually sometimes preferred just to use F and P's because we want you to understand that future value is just one value. It's not, FV is not two different variables. FV represents the same one variable. So when I rewrite these down, I'm gonna kind of use the F and the P rather than the FV and PV because I don't want you to think that F and V or P and V are different two variables. They represent one variable. All right, so basically in each of these problems, we're always determining the future value. So basically what we're just going to do is just plug in the information and then use a calculator to determine it. Now, you can plug in the information all at once and calculate it, but usually a lot of times that's where students make mistakes. So what I like to do is just kind of compute things one after the other, but I'll also show you how to use parentheses to make sure you're doing everything correctly if you are going to plug it into your calculator. All right, but first of all, we're finding future value, so we don't know that, so I'm going to leave that as F, is equal to, my present value says is 2,500. And that's going to be times 1 plus my interest rate, which is 8%, so that's going to be 0.08. Right? You got to make sure you put it into decimal form. So to decimal form is just be dividing that by 100. So 0.08. Divided by N is the times we're going to compound, how many times we're going to compound a year. In this case, we have monthly, so I'm going to divide that by 12. And then it's going to be 12 times the number of years, which in this case is 10. Now, obviously, we can simplify that to 10 times 12 we know is 120, but I'm just entering everything in at one time. Also, another thing is I wrote out the problems. I wrote out what each and everything is, but you'll also probably commonly find you'll see problems like this as word problems. So if you had a word problem, the main important thing is just to list out all the information you're given and then plug it in just like we're doing. Now, just like following the order of operations, what we want to do is when we're plugging something in your calculator to make sure we're doing everything correct. The number one mistake students usually make a mistake is not plugging in everything correctly. They either make mistakes as monthly as far as our N and not our T. They usually forget to convert your percentages to decimal form, and that's usually the main kind of issue students have. So once we've got everything down, written now correctly, we want to make sure that we're entering everything in correctly. So I'm going to do this one kind of step by step, and then the other ones I'll kind of do a little bit quicker. So following the order of operations, we want to do everything inside the parentheses first, right? PEMDAS. So we do everything inside the parentheses first. So inside the parentheses, I have 1 plus 0.08 divided by 12. Well, inside the parentheses, I again have to follow order of operations. So there's no further parentheses. There's no exponents inside the parentheses. But I have to do multiplication and division before I do addition and subtraction. So I need to do 0.08 divided by 12. So I'm just going to take my calculator and do 0.08 divided by 12. And that gives me 0.00667. Now, it's very important when using a calculator to not round your answers. And I have a problem with this is because I can't write an irrational number. That's 0.666 going on repeating. So I'm going to keep that answer, though, inside my calculator. And I'm going to use the second answer key to help me reuse that. Because if you round before the end of the answer, you can start making, you're going to have rounding errors at the end, and you'll get you're not going to get the exact answer we're looking for. Then I'm going to take this value and add it to 1, which fortunately for me, that's pretty easy. That's going to be 1.0066, repeating. Raised to the 12 times 10 is 120. Okay? Now again, another big mistake if students don't follow the order of operations. They want to multiply these two numbers before raising 1.066 repeating to the 120th power. We have to do that first because PEMDAS, parentheses, which we've already completed, exponents, and then multiplication and division. So I got to take, I got to add 1 to it. So I got to take 1.066 repeating, which I'm just leaving in my calculator. I'm just going to raise that answer to the 120th power. And I get 2.219640235. And obviously my calculator is only going to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places, which I think is pretty good. But again, I'm not going to round that answer. I'm going to keep it in my calculator. Even though 9 decimal places is probably not going to affect my answer because I'm only going to round it to the 100th decimal place, it's probably not going to affect it. It's better safe than sorry. Obviously, this could be a longer answer. Just depends on how many digits your calculator is going to approximate to. But then I'll take that answer and then I'll multiply that by 2,500. And my final answer, again, since we're dealing with money, I'm going to round to the nearest hundredth, 549. 0.10. So therefore, if you have an initial investment of $2,500 earning an interest rate of 8%, and you invest that money for 10 years, compounded monthly, at the end of 10 years, you will now have $5,549.10. Not a bad return on your investment, right, for not doing anything. Compound interest is doing all your work. All right, so let's go ahead and do the next one. So I have F equals, my present value is now 5,000. I have a lower interest rate, 0.06. Did I not do any of these? No, I kept these simple. Okay. 0.06 divided by compounds per year. Yearly is just 1 times 1 times 30. Now, you realize that 0.06 divided by 1, we don't really need the 1, right? So that actually brings us to another formula, is when it's only compounded yearly, we don't need to use this formula. We can simply just use F equals P times 1 plus R raised to the T, because what happens here is you can see that 1 is not really, right? We don't really need, we're not multiplying by 30 times 1 is just 30. And 0.06 divided by 1 is just 0.06. So that's a little bit of a shortcut. You don't need to really plug in those ones. You can figure that out. All right, so now I'll just do, what I'm going to do is 1 plus 0.06 is 1.06. And then I'll take 1.06, raise it to the 30th power. And again, my calculator is approximating to the 9th decimal place, which is pretty good for accuracy. But again, do not round it. Do not write in 5.7 and then multiply that, because I'll actually show you times 5,000. Then I'll take that answer, the whole answer that my calculator gave me, multiply that by 5,000. And what I'll get is 28,000. Whoa. 1.06. Oh, for 30 years, yeah. 28,707.46 as I round. So if you invest $5,000 for 30 years, you'll have $28,000. Now, just imagine, I want to show you something. If you rounded that, let's say you did, instead of that, you did 5,000, and you rounded it to 5.7, right? You didn't use the whole decimal place in your calculator. Let's see what happens there. 5,000 times 5.7. You now get 28,500, which, yeah, is close, right? I mean, it's both 28,000s, but you're missing out that $217 extra and 46 cents extra, right? So if it was a multiple choice, you might be able to guesstimate, what is going to be the correct answer, but you might not be able to. And I would mark this wrong as well, because you're not using the exact value. So you got to be very careful. Make sure you do not approximate to the end. All right, so for the next one, I'm going to kind of show you how to type it into your calculator. So again, we still want to write it out. Final value, we don't know. Present value is 1,000 times 1 plus 0.03 divided by daily. So how many days do we have in a year? 365. Or that's at least what we're going to use. 365 times 5 years. Okay? So if I was going to type this in my calculator, this is how I would type it out. And the main important thing is we want to make sure we're using parentheses correctly. So you're going to type in your calculator just like this. You don't need to write 1,000. So we'll do 1,000 times 1 plus parentheses 0.03 divided by 365 parentheses and double parentheses raised caret parentheses 365 times parentheses 5. Okay, so that's how you'd want to type in your calculator. The main important thing is putting those parentheses. So let's go and try that and see what our value is. So we'll do 1,000 times 1 plus parentheses 0.03 divided by 365 and parentheses caret parentheses 365 and parentheses 5. Now, I'm sure probably calculator you don't need to use maybe the parentheses of 365 times 5. But I just want to make sure that everything they know exactly what's actually. I'm going to do 365 times 5. Okay, and then I just go ahead and hit enter, and I get 1,161.83. Okay, so therefore, if you invest $1,000 at a 3% interest for 5 years daily, you're going to have or you're going to have a final value of 1,161.83 cents. I'm just going to do this individually, 365, just to make sure I did this correctly, because I just want to make sure that I typed it in correctly. That's interesting. Okay. Oh, I forgot to plus 1 raised to the okay, perfect. All right, now the last one, you can see that we have continuously. Now, what is continuously? We talked about, we dealt with monthly was 12 times a year, yearly was 1 time a year, daily is 365. What is continuously? Well, that's where our E is going to come into play. And the video is not going to be explaining E but we have a different formula for continuous interest. And the continuous interest formula is final value equals present value times E, which again is a irrational number, 2.71 approximately, raised to the R times T. So I have final value, which I don't know. My present value is 7,000 times E raised to the R, which is 0.05, times T, which is 20. Okay? Now, for this, there is an E button in your calculator as well as an E raised to a power that you're simply going to use. Now, you can do these all together, but I like just to plug this all in together. So I'll just type in 7,000 times my E raised to the caret, which is my second ln. And then I'm just going to type in 0.05 times 20. And when I hit enter, I get 19,027.97 cents. So there you go, ladies and gentlemen. That is how you determine the final value for compound interest. Thanks.